All right, so now let's go with creating a cube and then making it move. So I might want more than one cube, so I'm going to create a game object. Call it entities and use it to hold all the cubes and other things I might create. I should probably call it movable entities, right? Inside it, I'm going to create something else. So first, let me call it movable entities, because these things are going to be moving as opposed to the ocean, which is not going to move. And this is going to be holding my cube once I get my cube mesh ready to go. So this is my cube entity. So let's make sure everything is at 0, 0. So for some reason, when I created this was not at 0, 0, 0. So it's something you should watch out for. Unity occasionally puts things in different places. Reset will set it to 0, 0, 0. Cube entity also at 0, 0, 0. Everything is fine. Inside cube entity, I'm going to create not an empty game object, but a cube. And you can see I can create lots of other things, and you can play with that. I'm going to create a cube. It's been created. Where is it? I don't see it. There it is. Seems kind of small. And I can't really see it with my camera here, or can I? Let's play. Yeah, I don't see it really. Okay, let's try to make it larger. So obviously we want to scale it. Let's make it 10 times. Ah, there, I see it already. Okay, so now you can see it there. It's kind of a pure white, shiny white, and the reflections from the sun seem to be making it difficult to see. What I'd like to do is to perhaps change the color. To do that, I'm going to have to create a new material. But before we go there, take a look at this cube. That's what I've selected, right? This is an empty game object. Think of it as a scene node inside which I put this cube mesh. But the pre-built cube mesh has a few things. It has the mesh, it has a transform attached to it, and I've scaled it by 10, 10, 10 in each of the 3 directions. It has a renderer attached. If you turn off the renderer, it disappears from view. Only things that have a mesh renderer attached get rendered and appear. I can turn off the cube and it disappears from view as well. So different ways of making things visible and invisible. And we'll talk about the differences. This just makes it makes the graphics card not render it. It does not get the orientation and position do not get computed, and it does not calculate light shining on it or getting reflected and all that kind of stuff. Nothing. It also has a collider. So this is useful because if you need to worry about cubes colliding with other objects, maybe other cubes, and you want to know, a box collider attached to this essentially can call a function in some code that you write every time this box collides with anything. All right. For now, we won't use it. And the default material here, which if I click on, expands to all this, which is not editable at this point, kind of is what's being used to give this thing this weird white color. So what we're going to do is, and this is something useful to know, I'm going to turn off the box collider because that takes compute resources. And I'm going to, inside assets, I'm going to create a folder, and inside that folder, I'm going to create a new material that I will use to give this cube a new color. All right, so here's materials. And all I have to do is say create, and instead of folder, I can create all kinds of things, including materials. And I want to call it, what should I call it? Well, we'll figure that out in a bit. So what I'm going to do is change what it looks like. I want kind of orangey, maybe brighter orangey. Oh, it's kind of, maybe, is that brighter? No, it's still kind of, well, okay, we'll go with kind of that way. All right, let's go with that. And you can see that this, you can see how it's being shown as you change things. You can see that the color changes here as well. Very interactive, very nice, kind of easy to use, especially for beginners. And there's a lot of shortcuts and things that make it easy to good to use for non-beginners as well. We'll call this, I'll triple click this and call it burnt orange or orange. Okay, all right. So now, how do I associate it with this white cube? Well, I click on the white cube, and it turns out that in Unity 2018, what you have to do is you have to bring it and drop it over here. You bring it down, you drop it over here, and you can see the icon changing. If I move it somewhere else, it says no, here, no, 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 oh, no, no. I don't want to give it another one. I'm just going to bring it down here and add it. Okay. Gets rid of the old one, gets the new one, and here we go. So we have a nice cube. It's 10 by 10 by 10 on the side, and we're ready to start moving it. Well, in Unity, you write code, scripts to do things, and in general, you attach those scripts to existing objects in your scene. This way, it becomes part of Unity's render loop, or Unity's game engine loop. And you'll see what this means when I create a script and attach it to my cube entity. Add component. I can attach all kinds of things, but for now I'm going to attach a new script. I'm going to call it physics and input, because it's going to take input from the user with the arrow keys, or the AWSD keys. Let's just do arrow keys. And it's going to move this cube. Notice that it took a few seconds for this to be noticed by the editor, and then the name changed from new script to physics and input. Notice that it automatically puts spaces in between, even though I didn't have spaces in the name. So I'm going to edit this script, and when you click on edit script, it opens up the stuff. I'm going to sign in. Give me a sec. Patience, apparently it might take a few minutes. No, it's running. Okay, yes, please allow access. Oh no, it's not a public network. Damn it. All right, so you can see that a window comes up. It's got the nice dark mode. I like it. And this is in C#. If you don't know C#, don't worry. It's really similar to C++. It's got the best parts of C++ and Python. So this is like an include. It's a mixture of include and using in C++. So it names a namespace, and it um, includes all the functions and classes that are in that namespace. So system.collections gives you access to lists and queues and all kinds of other data structures. Generic versions gives you templated versions and even more data structures. Most importantly, Unity Engine names a space and a collection of code that allows you to work within the Unity game engine. So you notice that we have a public class physics and input, which inherits from mono behavior, right? We need to override start and or update. Update is like our tick, start is like our init. And you can think of this as an aspect or a manager. Right now, we're not at the stage of making aspects and managers. If you think about what we did in 381, this is a piece of code that was attached to our cube entity. So it's most like an aspect. But unlike the aspects that we wrote later in later assignments in 381, this particular aspect also handles input, which in our assignment was handled by the input manager. But if you recall, in assignment 2, everything was mixed in. And that's how you should think when I'm doing this particular little tutorial. So just like with the assignment, I'm going to create a vector which comes with Unity, a vector 3, a 3D vector called position, and another one called velocity, right? Because user input is going to change the velocity, and all I'm going to do every tick is say position equals position plus velocity star dt. Okay, so dt, it turns out there's a global variable called time, and in there is some delta time tells us the time between every frame, the time between calls to update. All right, we haven't initialized position or velocity, but I want you to notice once I've saved this and switched to this that those two public variables now appear here. Okay. If I change this, I've essentially given it an initial value. I think I'll make this 0, 0, 0, 10, 0, 0. So I can actually set initial values here, and they are incorporated here. The start is called before the first frame update, and it's called once. Update is called every frame. Okay. I could have initialized it here. So if I do this, and play, my position is changing at this velocity, but the cube is not moving. Why? Because I changed a variable that I created, but I haven't actually changed the position of the scene node. Okay, so because this script is part of cube entity, it has access to cube entity's transform. Okay, and transform has this position. When this changes, so for example, if I say 10, you can see the cube move. When that changes, the cube's position will change. So what I have to do in my code is say transform dot local position equals position. Save this, go back, wait for it to finish compiling at the bottom. Compiled, ready to play, and you can see it starts moving. The reason it's moving this way in this particular view, in the scene view, and this way, is because the camera is looking this way, but we are looking this way. So what camera? This camera, right? It's looking that way, and that's the view we are seeing here. So if we want to kind of synchronize both, what we need to do is to kind of look at it from a slightly different perspective. Let's not worry about that for now. Instead, what we will do is, well, we can kind of look at it from the camera's perspective. Middle mouse button moves. Left mouse button is used for selection, so don't use that. Right mouse button rotates. So if I go kind of like this, then I can, right, like this. If I look at stuff, I'm looking at it almost from the same perspective as the scene camera. Okay, so now if I look at it from here and I press play, they should both move right. Right? Different perspectives, but they're moving right. Okay, cool. So now what I have to do is go back and say, all right, I don't want you to have an initial velocity of 0. I can do that. Or I can leave this at 10 and simply say velocity equals velocity dot 0. No, it's not velocity dot 0, it's vector 3 dot 0. Okay? I think we're cool. So, so that'll initialize it to 0. What we want to do, though, is every update, as we did in our early thing, process input, which will change velocity, and then change our position. So how do I declare process input? Void process input. There we go. And once I declare it, you can see that the little red underline went away. What should it do? Okay, how do I get access to input? Well, let's look at just up arrow, well, left arrow, right arrow. So we'll go left and right according to this. So you get access to input because Unity has an input manager, and it's called input, and it has a way to get key. I meant get key, not key get. And because I was thinking about key codes, and there are key codes for, shall we do left arrow or right arrow? Let's do left arrow. I love this autocomplete stuff. And what should it do? Velocity.x minus equals 10. Well, maybe not 10. I should say public float delta velocity equals 10. Now, let me show you a few things. One, if I say float delta velocity, save it, go back here, it finishes compiling, it gives me a warning, it's not a big deal, but I don't see delta velocity here. Okay. If I make it public, save it, and go back, every time I bring this window to the foreground, it recompiles that code, And now you can see delta velocity here. Notice once again that it's capitalized and the spaces. I can change this value to say to 5. I'll start with this low value. So that's the advantage. You can try different values and run with different values when you make public variables. On the other hand, you are giving access to anybody who has access to this particular object. So at this point, what I need to do is change this to delta velocity. Oops. Save it. Now I'm going to need 2 of these. So cut it, paste it, paste it. And if it's right arrow, I want to add velocity. Let's just make sure we can do this. Go back here. It's let's change this to 1 and play. So nothing is happening. Right arrow, 3, 2, 1, right arrow, 3, 2, 1, left arrow. Okay, it's going nice and slow. None of the other arrows work. Okay, that's kind of slow. Note that if I change this here, and then press the right arrow, after I bring the cursor here, the changes are much more. Okay, so it actually rereads these while things are running. Okay. So let's try some value like 5 in between 1 and 10 and see if that works for us. Right? Okay, that's fast enough for me. Yeah, not bad. Okay. Oh, I was hitting the spacebar, but I don't have code that makes it stop the spacebar. So let's go back to the code, and here we go. Now I need to do up, down, and the z-axis as well. So cut, paste, paste, paste. Okay. So should we do up, down? All right, let's do, no, up, down arrow. So up arrow is going to do velocity.z, and it's going to be plus, and down arrow is going to do velocity.z, and it's going to be minus. Then I think we'll use page up and page down. Page, no, it's page. Okay, so page up. Well, let's do page down because then it's easy to. We don't have to change the sign because page down means it's going down. And this is page up. Right? Okay. And this has to be Y. Okay, save it. And then one more time, I'm going to write this out. Get key code. There's a key code dot space. And what do I want to do? I want to say velocity equals vector 3 dot 0. Okay. So this should do stuff for me, right? So here we go, and let's play. So now, up arrow, 3, 2, 1 up goes in, 3, 2, 1 down, 3, 2, 1 left, 3, 2, 1 right, 3, 2, 1 down, left, right. Okay, let's check page up, page down. No, stop, stop. Okay, left or right. So that's done with assignment 2, I believe. We have it all working. All right, let's talk about building an executable. Open build settings. What do we want? We want Windows and thing. Add open scene. It's going to add the current scene. If you look at the current scene, it's called sample scene, and it's not actually been saved. So I'm going to stop you for a minute, save you, no, save you, and then do the build again. So build settings. All right, scene, sample scene, build. What does it do? Where should I put it? 381 AS2. All right, let's put it at 381. Let's create a new folder called builds, because we'll put all our executables in here. And it's a slightly different way of doing things. And we'll select that. And it's starting to build. Again, a little bit of patience will be good. You'll see things change. And when it's done, it'll bring up, it'll open the folder automatically. Open it somewhere else. I'll bring it into the view. And that is it. Double click to run it. Let's make it smaller than the size of the window. Let's say that we want it windowed. Let's say we want it, high quality. And let's say we wanted this display. I thought I said I wanted it windowed. All right. Up arrow, left arrow, right arrow, page up, page down, stop, come towards me, turn right, there we go. So, stop, down, stop, left, right, do. Okay, so it's working. How do I get out? Uh-oh, I didn't put any input processing. How do I get out? How do I get out? Luckily, I know some shortcuts. Alt F4 kills Windows. So I didn't click on windowed. And I guess I should have done that. Okay, that's what I wanted. So then once I'm done playing, right, I can click on this to kill it, right? That's it. That's how you create a executable and run it.